Welcome.
Thank you. I will try to keep you on earth. All right, so let's make a language test. Question for you. How many of you believe this photo was taken outside the building? Hands up. Of course, you are perfectly wrong. I mean, you are not wrong. You are the perfect audience to talk about biomimetics. As this concept involves a set of innovative technological solutions developed on the basis of natural systems observations. So today, I want to show you what we can learn from nature, how we can learn from nature, and how we can apply this knowledge into contemporary architectural design, which is, of course, closest to my heart. So, in contemporary architecture, biomimetics is one of the most actual phenomena. I believe the popularity of this topic may be attributed to the development of close links between biological sciences and innovative technologies. So, of course, it didn't start yesterday. In Art Nouveau, already at the end of the 19th century, architects started to look at nature as the best source of inspiration. And that was later developed in so-called organic architecture in the 20th century, where engineers used to observe natural structural systems, like trees, and used to apply these observations into their building and structures. Oh, spiderweb, the one I hate. But that's very popular tensile structure existing in nature, which was an inspiration for the pretty famous Olympic Stadium in Munich. So what has really changed? Why we speak about biomimetics today? First of all, we developed a more holistic approach. We look at the whole systems. And secondly, we started to change our attitudes towards environment, climate, sustainability. All right, so what does it really mean, biomimetics? The term was first used in 1969 by Otto Schmidt in the context of opportunities arising from applying the knowledge from the field of biology in medical engineering. And since then, biomimetics has been a fast-developing tendency that provides an information transfer from biology to technical disciplines with purpose to understand natural systems and processes and to implement them in concepts and structures designed by humans. When we think today about biomimetic design, about biomimetic building, first we carry out so-called natural systems behavior analysis. If that sounds a little bit complicated, let me make this simple. We look at exchange mechanisms between external and internal environments. And now those of you who listen carefully may want to stop me with a question. But is it ever possible to compare something that's so different? Biological systems, living organisms, and building that is obviously not alive. So can we say that the buildings breathe, consume, digest? Even worse, can they reproduce themselves? Aha, I see your faces. Some of you look a little bit nervous right now. No worries, I promise. I am not going to show any building pornography, any procreation systems of the buildings. But yes, in a sense, they can. They carry out a series of metabolic processes. And I will show this in a moment. But the main purpose of biomimetic design in architecture is to create completely new, complex solutions that are based on biological systems. Let me explain this with this example. You can see this biofiltration wall system, and except from pretty interesting architectural design, you can see green plants here. And these green plants make a part of biofiltration system. As they breathe, they produce oxygen, they absorb carbon dioxide and air pollution. So we can say that the plant's breathing mechanism is an example of biological process applied in the building. However, biological processes represent a huge variety of complexity. I hope you would agree that one can notice a small difference between complexity and intelligence of processes occurring in plants and in humans. Even though some politicians seem to represent a small exception from this rule, let's just believe it's a general idea that similar is not identical. So some further research is necessary. A simple copy of the biological system would not work correctly in architecture. So how do we analyze these systems? Let's take a look at multi-level research model of biomimetics in architecture that I developed. And it always starts with something very simple: selection and observations of biological prototype. It can be something as simple as a leaf. What do we analyze? Structure, function, reaction for stimuli, physical-chemical properties, relations with environment, anything that we believe may be important and inspiring. The only thing we need to remember is to look at it like we have never seen it before. As remember, we are trying to develop some new knowledge here. So from here, we can move to the second level, from the leaf to the whole branch. And when first all the solutions were analyzed individually, then we look at them at the system level. And again, there is a huge complexity of biological systems. So to simplify the model, I have selected 3 basic systems that are similar in nature and in building. And these are structure, metabolism, and skin. So we continue observations, we apply the research result in the built environment, and we do not stop here. We continue research and we try to improve the functioning of the building, hopefully for the benefits of the users, not just architects. And from here we can move to the third level. As for complexity, it can be compared to the whole tree. At the third level, we look at passive, active, and hybrid solutions, and we test them for practical verification of the model. So we follow nature also in the process that's similar to evolution, as we try to select the good ideas and eliminate the concepts that do not work so well, at least currently. So this is how it looks as a model from biological prototype through selected systems, structure, metabolism, and skin. And these particular solutions I would prefer to explain on existing architectural examples. Like this building designed by Mario Cucinella in Beijing. And we will start with structure. So, as you can see, some parts of the building can move. And this is because flexible systems can adapt their structure and shape to changing environmental conditions. This can happen on passive, active, or hybrid mode. And this is something similar to what living organisms can do. Like opening and closing depend on temperature, humidity, solar radiation. At a passive mode, you can see the example of the same building, that's just a schedule. And the building was designed for a particular angle of sun during the year. So you can see that in winter, with lower position of the sun, solar radiation comes directly on the facade to provide passive solar gain. Speaking English, it means to warm us when we are in the office. In summer, when we prefer to avoid overheating with higher position of the sun, a part of radiation would be reflected from the shadowing devices, which simultaneously convert the solar energy to electricity, as this we have photovoltaic panels, and a part is absorbed by green plants and used in photosynthesis. It's an amazing building. I could spend a lot of time speaking about this, but I can't. But I would prefer to show you some active structures that can provide adequate reaction for the external stimulus. And a specific example, very promising for future technologies, are pneumatic structures, pneumatic systems, especially the ones based on membranes. Like Gore-Tex is an example of complex hybrid membrane. And the especially interesting membranes, they combine durability of synthetic membranes, they are strong, and selectivity of cell membranes, so they can breathe. Also, some advanced strategies for heating and lighting can be inspired by phototropism. I'm sure you know some phototropic or heliotropic plants like sunflowers that follow sun during the day, and the same can happen to some elements of the building. This is often combined with adaptive building skins and simulated metabolic processes. So here we are at the mysterious level of metabolism of the building. Let's see what do we deal with. First of all, there is a series of exchange mechanisms between the building and environment. Buildings exchange gas, so we can say that they breathe. Sometimes phototropism is involved and photosynthesis. And there is exchange of liquid, like water intake or elimination of too much humidity, so we can compare it to evapotranspiration. Plenty of processes related to energy. Consumption, absorption, production, transformation, and waste management, because the buildings and the users produce waste. But it's important that in nature, nothing is really a waste. Anything can be important source for something or someone else. So we can say that basically biology operates on well-designed circular economy models. There is also a steering system that we can compare to our central nervous system. In case of the building, such a brain is called BMS, and building management system in the real time selects the most appropriate strategy related to energy, humidity, thermoregulation. Also, hybrid thermoregulation can be inspired by heterothermic organisms. The ones, they adjust the body temperature to external conditions. In energy efficiency center in Würzburg that you can see here, it is possible with heat storage in phase change materials. And it is a fantastic materials that transform their state from solid to liquid, depending on the temperature outside and on our needs. Also, it is supported with heating and cooling with infrared radiation technology. You can see the system working here. And at the skin level, we have a series of controlled metabolic processes: radiation, convection, and evaporation. And these processes work very well in combination with green roofs and green facades. Some of those are inspired by traditional architecture, like from Scandinavia, and they are very good because they provide excellent insulation, they help us with humidity control, and they also produce oxygen, so that with higher partial pressure of oxygen, our cognitive processes should work actually really well. Oh, here. It's again about phototropism, because some advanced building skins can involve third generation of photovoltaic cells, like this one with Fresnel lens and polygonal photovoltaic cell, transparent cells that allow for harvesting of that part of energy which was not converted to electricity. But okay, now I believe it's time to show you the biomimetic design concept in Brit, Austria, which was Austrian Pavilion for Expo Milano 2015. And the building was so spectacular because it was a real hybrid of nature and technology. The building had a very simple wooden core, but inside of it, and that's the where the photo was taken, there was a copy of Austrian mountain forest with over 12,000 of green species that the plants would produce oxygen enough for 1,800 visitors per hour. So how was it possible that the system, the natural system, was so efficient? And this wasn't me. This was because natural processes, evapotranspiration and photosynthesis, were supported with active technologies powered with photovoltaic energy. And the ambience was absolutely amazing, because when you would enter the pavilion from the middle of very hot Italian summer, you felt like you went into the forest that was cold and humid, and of course you could see the technology which was exposed in a clearly visible way to explain how the system works. There were fans and fog nozzles and sprinklers. So the impression was so fantastic, even with the play of light between the trees. And of course, I'm not saying that this building was a prototype for mass production. No, we should look at it as at the experiment that proved that we have knowledge and technology to create biomimetic buildings that are safe for environment and comfortable for the users. But the real secret is the novel perception of the built environment. And this is related to shifting baselines regarding sustainability, climate, ecosystems. And this is why I'm showing children here, because you surely noticed how natural children are with all kinds of innovative technologies. Smartphone, laptop, just robots, name it. And the same should happen to their attitude towards nature, towards renewable energy. The sooner we start the education, the better chances that we will grow a real post-fossil generation. And also the role of the building in the future should evolve from sustainable or less harmful relation to something that we can call endosymbiotic living environment for humans, or biological architecture that uses the same concepts that biology. So next time, when you feel that the big city is not so sexy anymore, instead of your usual gun fishing, you can say, take a walk on the wild side, or if you live in biomimetic building, you can just say, let's go home. And that's my message for today, because learning from nature can be absolutely amazing. And I hope you will open your eyes and enjoy the experience, and let's keep nature reloaded. So thank you very much for being such a wonderful audience today.